To perform electrical termination of a MI cable, firstly, peel the cable jacket back approximately 1 to 1.5 inches. Secondly, cut the outer shield back flush with the jacket. Thirdly, straighten the braid and fold it back over the jacket. Fourthly, cut the inner insulation back approximately 0.5 inches. Fifthly, strip the individual conductors back approximately 0.25 inches. Sixthly, twist the conductors together to form a solid connection. Seventhly, solder the twisted conductors to the appropriate terminal block or connector. Eighthly, insulate the solder joints with electrical tape or heat shrink tubing. For mechanical termination, firstly, install the strain relief. Secondly, slide the strain relief boot over the cable and push it down until it is securely seated. Thirdly, tighten the cable clamp by using a wrench to tighten the cable clamp until it is securely gripping the cable. Fourthly, secure the cable jacket to the strain relief boot using a cable tie or zip tie to secure the cable jacket to the strain relief boot. Some helpful tips and tricks include the recommendation to use a sharp knife to cut the cable jacket and insulation. Holding the cable steady while cutting to prevent fraying or nicking is crucial. Twist the conductors together tightly before soldering. Use a low-watt soldering iron, such as one rated for 25 to 40 watts, to avoid damaging the conductors. Insulate the solder joints thoroughly to prevent shorts. Make sure the cable is adequately secured to the strain relief boot to prevent strain on the connections. The process of electrical termination involves several key steps, starting with preparing the cable. Peel back the cable jacket carefully to expose the internal components. The amount to peel back, around 1 to 1.5 inches, allows for sufficient working space without exposing too much of the internal structure prematurely. Cutting the outer shield flush with the jacket ensures a clean and safe transition point, reducing the risk of shorts or ground faults. Straightening the braid and folding it back over the jacket serves multiple purposes. It provides additional shielding, reinforces the cable's grounding capabilities, and offers a more secure surface for further connections. Cutting the inner insulation back by approximately 0.5 inches prepares the individual conductors for stripping and connection. Stripping the individual conductors back by about 0.25 inches exposes the conductive material needed for making electrical connections. Twisting the conductors together tightly before soldering is essential. This step ensures a solid mechanical connection, which in turn provides a reliable electrical connection. Soldering the twisted conductors to the appropriate terminal block or connector creates a permanent and low resistance joint. Ensure the soldering is done correctly to avoid cold solder joints, which can cause failures. Insulating the solder joints thoroughly with electrical tape or heat shrink tubing is the final step in electrical termination. This insulation prevents shorts and protects the connections from environmental factors such as moisture and corrosion. In mechanical termination, installing the strain relief is paramount to protecting the electrical connections from physical stress. Sliding the strain relief boot over the cable and seating it securely provides a buffer against pulling or bending forces. Tightening the cable clamp until it securely grips the cable prevents the cable from being pulled out of the termination point. This is a critical step in maintaining the integrity of the connection over time. Securing the cable jacket to the strain relief boot with a cable tie or zip tie further stabilizes the cable, preventing movement and reducing strain on the internal conductors and connections. When executing these steps, remember a few key tips and tricks. Using a sharp knife for cutting the cable jacket and insulation is essential for clean cuts. A dull blade can cause fraying and make the process more difficult. Holding the cable steady during cutting prevents nicks and damage to the internal components, maintaining the cable's integrity. Twisting the conductors together tightly before soldering is crucial for a strong and reliable electrical connection. This ensures that the solder has ample surface area to adhere to, creating a robust joint. Using a low-watt soldering iron, such as a 25 to 40 watts model, minimizes the risk of overheating and damaging the conductors. This is particularly important for delicate wiring where excessive heat can compromise the insulation. Insulating the soldered joints thoroughly with electrical tape or heat shrink tubing is a non-negotiable step. This prevents shorts and protects the connections from moisture and corrosion, ensuring long-term reliability. Ensuring the cable is adequately secured to the strain relief boot prevents strain on the connections, prolonging the lifespan of the installation. This reduces the likelihood of failures due to physical stress on the electrical terminations. The overall goal of both electrical and mechanical termination is to create a safe, reliable, and long-lasting connection. By following these steps and tips, one can ensure that the MI cable is properly terminated, minimizing the risk of electrical faults, mechanical failures, and other potential issues. These procedures align with standard practices for cable termination and contribute to the overall safety and performance of electrical systems. Always consult with applicable codes and standards to ensure compliance and best practices are followed. Proper termination techniques are essential for any electrical installation, particularly with specialized cables like MI cable, where the integrity of the termination directly impacts the overall system performance. These methods, combining both electrical and mechanical aspects, provide a comprehensive approach to cable management and connection reliability.